So it's not like, say if lose our compass or don't have the protractor, it's not critical. As long as we understand the math, we can still get the answers. It's just drawing an accurate circle helps you check your answers, right?
Yeah, you can. Can you say again about checking your answers, right?
Yeah, like you want to draw an accurate circle so that the math and what you're seeing on the diagram.
Yep. You can sketch. I don't mind you sketching. Okay. Right.
Okay.
Right. So now we are going to go into 3D Mohr Circle. Right. So 3D Mohr Circle is three circle. Okay. 3D Mohr Circle is not that you have a sphere, you have shadow, nothing like that. Okay. So what you see now down here is an element. So now the element, we have to consider three faces, right? So the three face that we have to consider is this face that is your x, the plane intersecting the x plane, x-axis, the plane intersecting the y, and the plane intersecting the z. So likewise, you have stress x, stress y, and stress z, and then you have your shear xy, shear yx, so on and so forth. You have your shear xz, shear zx, shear xy, shear yz. Okay, don't panic. It's not that complicated. Okay, but there's one term that you have to learn. Okay, what do they mean by in plane, and what do they mean by out of plane? This is the most critical thing. Okay, so in plane is basically the element where the surface area is the largest. Okay, so for this case, this surface, right, that I'm drawing now, or this square that I'm drawing now, is on the xy plane, and the surface area is the biggest. We call that in plane. Okay, and then the other area, the other surface, this surface that I'm sketching in yellow now, and it's not big, is it? Okay, this surface now that I'm sketching now, again in yellow, right, that you can see now, right, it's also not that big. That is what we call out of plane. Okay, that's all. Okay, you cannot find this in textbook. They so-called, it is unknown that in plane is the bigger surface area, out of plane is not. Yeah, I did not know that. Okay, but anyway, so in 3D Mohr Circle, there are three conditions. Okay, so I want you to look at this. So from here, from the element, I want you to look at the element now, right? So this is your xy plane, and your xy plane now is the biggest area. That's your in plane. Your out of plane is your xz plane, and your out of plane is your sorry, that is xz, and I got it wrong. So that is your x, and this one is your yz plane. Sorry. So this is your yz plane. Okay, z. Oh, I got it opposite. No. That is correct. Sorry, my bad. The first one is correct. It's the second one is wrong. Okay, so my apologies. So this is your xz plane, right? Is this one that's wrong? Okay, so this is your x. This is your yz plane. Okay, so the yz plane is your out plane, and your xz plane is also your what? Your plane, because the area is the smallest. So we have one condition. Okay, stress x is equal to 0, right? Stress z is equal to 0, right? Stress x is greater than stress y. Okay, so when you draw Mohr circle, right? So when you draw Mohr circle, you will I think I'll draw this physically, what you see first. Okay, right, what you see first. I think that's more important for me to start drawing now. Okay, so you will have your x, y, and z, and if you look at this element down here, the shear stress are all 0. Okay, so the first circle that you draw is your xy. Okay, so you draw your xy. This is your first circle. Right? So this is your xy, and this circle is your in plane. Okay, I repeat again. This circle is your in-plane circle, is because the what? The surface area is the biggest, okay? And then the next circle that you can construct is your YZ plane, okay? So this is your YZ plane. Right? So this circle that I've just constructed, as you can see down here, this is your what? Your YZ plane. And the last circle you construct is touching the extreme point of X and Z, okay? So 8. So this is your last circle. Okay. So the final circle over here, that is your X and Z plane, and that's your biggest circle. So some of you might say, Eugene, you know what? Why? Can someone tell me why do we need to do this? Anyone? Why do we need to construct 3D Mohr circle? Anyone?
It's the world's 3D.
The word is 3D. What else?
For forces acting on different planes?
No. Okay, I'll tell you this. Okay. So now, we know that stress Z is equal to 0. Yes or no? Right? So now, if we just construct a 2D Mohr circle, now let's say we just construct a 2D Mohr circle, right? We construct a 2D Mohr circle. Okay, we ignore the 3D. Why we ignore the 3D? Because stress Z is equal to 0. Stress Z is equal to 0. 0 means 0, 0, right? Right? So we know that this is our point X. This is our point Y, right? So this is our stress X. This is our stress Y. If that's the case, we only construct one circle. We only need to construct this circle over here, right? The one that I'm highlighting in yellow now. We only need to construct one circle, right? So that one circle that we construct will have the maximum shear stress at that magnitude, okay? And we all know that if anything is going to fail, it's not going to fail in normal stress first. It's going to fail in what? Shear stress. Because the shear stress magnitude is less than the what? Normal stress, right? So you ignore it, you calculate your maximum shear stress, and this is the height that you get. You totally ignore the Z, right? So this is where, now when you see this tree circle, right? Which one has the maximum radius? Can someone tell me, please?
XZ.
XZ, yes or no? So now when we consider the third point, which is the Z point, then we are able to construct the circle in pink. Yes or no? Then we can construct the circle in pink, right? Then we can construct the circle in pink, which I'm highlighting now. Then we have the actual what? We have the actual tau max. And the maximum shear stress is no more in plane. The maximum shear stress is running at where? The maximum shear stress, as you can see down here, the maximum shear stress is what? Is out of plane. And this is why 2D Mohr circle is to understand the mechanics of Mohr circle. 3D Mohr circle is where it's useful. Are we clear? Okay, that's why I don't want you, okay, we just know 2D. Oh, we are done, we are good to go. No. Okay. Over here, we assume that stress Z is equal to 0. When we assume stress Z is equal to 0, does not mean that you can ignore stress Z at all. Okay. So from here, you can calculate your actual maximum shear stress. So if you look at the formula, right, the maximum shear stress now, right? Oh, the maximum shear stress now, right? The maximum shear stress is out plane, and this is where stress X is, and you just divide by 2. That's it. Okay, that's your maximum shear stress. Okay, now let's look at another condition. So another condition is where stress Z, okay, condition number 2. Okay, so for condition number 2, stress Z is equal to 0. No problem. But now stress X is negative, stress Y is what? Positive. Okay. So now, as you can see down here, we are able to locate 3 points on Mohr circle: point X, point Y, and point Z. Because point Z have what? Zero normal stress. Then you can construct 3 circles again. Okay, like what I did before. You draw your first circle, which is your XZ plane. So you construct your XY plane first. Okay. Then after that, you construct your XZ plane. And then lastly, you construct your YZ plane. Now, for this case, we happen to be real lucky. The maximum shear stress, the biggest circle, is on the what? XY plane. Okay. So if you have stress state as in condition number 2, right? It's okay if you don't look at the stress happening on Z. It's okay. But I want you to practice this. No doubt you know that you have to check, okay? You have to check condition number 2, okay? I know some of you say, hey, if I have normal stress X and in compression, Y is in tension, or vice versa, stress Z is 0, I can do 2D Mohr circle. No, I want you to have a mindset to check as an engineer, okay? So we know that tau max is in plane. So the formula is stress Y minus stress X divided by 2. You don't need the formula. You just look at the circle. You can calculate already. Okay. Or you can call it stress max minus stress mean divided by 2. Okay. Right. And then this is condition number 2. Right. Now, when we come to condition number 3, right, when we come to condition number 3, now stress X, stress Y, and stress Z all have direction. Okay. And this type of structure with all 3 direction, or all 3 of them have direction, is usually a pressure vessel that is submerged in water. Then you can see stress X or 3 stress states. Okay. Usually stress Z is 0, X and Y has magnitude. Okay. So from here, you construct your 3D Mohr circle again. And what you realize is, so the thing to focus on now is XY is your in plane. Now your XY is not the biggest circle, right? So your in plane is not the biggest circle anymore. Now the biggest circle is your what? Is your XZ plane, is your out of plane. So your tau max again is your what? Is your out of plane. Again, you have to analyze 3D Mohr circle. Okay, in this situation. Okay, so i.e. you have to plot your stress Z. So from here, you can calculate your tau max. Right. So that is 3D Mohr circle, right? And I believe you have no question. Anyone has question, please? Anyone?
What does in plane and out of plane mean?
I just told you. The area. The one with the biggest area is in plane. The one that is the smaller area is your out of plane. Okay. So like how I show you now. How I show you in my. I'm going to stop sharing my screen. Okay. Now you can see me big again, right? Like this element that we have drawn. The in plane is this surface over here, right? The out of plane is the depth. That's it. Okay, that's it. Okay, physically. Okay, let's do, so I have 2 examples to do. Okay, let's do example number 1. Okay, so let's look at example number 1. So at example number 1, it shows an element now. Okay, so this element has stress X is equal to minus 120. So I write this down. Okay, right. So this is X. This is Y. And now you have to include Z. Okay. So you write down stress X is equal to 120 megapascal. stress Y is equal to minus 60 megapascal. Shear XY is equal to shear YX. And now you guys know that it's positive shear, but does not mean anything in the terms of shear. And then